So real quick in the chat, can everybody hear me okay? All right, fantastic. All right, well, yeah, thank you for attending this talk. My name is Johnson-Bey. I'm a second-year PhD student at UC Santa Cruz, and I'm a part of the Expressive Intelligence Studio with Michael Mateas. Centrifuge is a visual programming tool that helps people author sifting patterns for character-based simulationist story worlds. There we go. So I threw this slide in last minute because I realized I actually haven't had the pleasure of meeting many of you here in the room. So that you can know a little bit about me, like I said, I'm a second-year PhD student. I have a master's in biomedical engineering from Carnegie Mellon University. And then I have 2 Bachelor of Science degrees, one in neuroscience and one in computer science. And both of those are from the University of Delaware. And I currently do interactive narrative and multi-agent simulation research as a part of the Expressive Intelligence Studio. I like to make content creation tools for games, so like procedurally generated swords, city and town generation, and story sifting. Fun fact, I'm a food blogger, and I recently started a small startup company with my partner and we help people find Black-owned food businesses in DC, Maryland, and Virginia. Okay, back to the technical stuff. We're going to start off with some key terms. So visual programming, for anybody who isn't familiar with it, just helps people create programs by manipulating graphical elements versus using a textual syntax. Sifting patterns, which are at the core of what this project is about, help folks specify what they're looking for when they're combing through a simulated story world that has a mass of characters, events, and other forms of data. And then finally, this term simulationist, which refers to simulated worlds that rely on the bottom-up interactions between systems to have content emerge out of them. So they're very much a an emergent narrative dependent tool. So story sifting, what is it? Why do we care? So it's the process of finding interesting characters, event sequences, scenarios, and other stuff just within a busy narrative world. So getting back to that simulationist aspect of it, it's not relying on, let's say, a planner to come up with interesting narrative scenarios and making sure that those happen in the world. It's very much depending on these bottom-up systems to align in such a way that interesting things come out of it. And one of the strategies that people use in order to guarantee that that happens is just make a lot of stuff. But when you make a lot of stuff, it's hard to find what pieces of that stuff are actually interesting, because a lot of it could be just very mundane things like, oh, you have a character that just goes to work, comes home, and rinse and repeat every single day. Or you could have some other character that has all types of conflict going on between their personal worldviews and maybe the job that they have, or the events that have transpired between them and other characters in the world, stuff like that. And so you just need a way to go through, find those characters, and then surface them up to a player, or the designer could use it as a part of a tool to say, okay, what's going on here in this world? Is there interesting stuff that is happening, or do we need to tweak something? And so patterns can be executed by either manually searching through the world. So this is more of a pen and paper approach where you personally know what it is that you're looking for. And so you're just combing through some simulation output and trying to find exactly what you're looking for. You can automate that process using code. So this is probably going to use whatever language the simulator's written in, saying, okay, yeah, I'm just going to write this a couple functions that go through a bunch of for loops and say, okay, look for these conditions, return to me everything that you find. Or you could use a query language if your system is set up in such a way that you're able to do that. And I've touched on this before, but part of why do we care about it is designers could use this as a way to surface content to players. So let's say you've got a busy story world going on, something interesting happens over in some little corner that maybe the player is not noticing. Well, you could have some story sifting sort of built in that says, ooh, this interesting thing just happened. I think the player should really know about this. And then you can notify the player in some way. Maybe the players themselves just want to explore the simulation. I touch on this a little bit later in another slide. Or this is another thing I talked about, designers could use it to characterize sort of the narrative potential of their simulated world. So like what stories are emerging? Is it enough to meet like my personal standards, or is there something that I need to go back and tweak in order to have like more certain types of stories emerge from the underlying systems? So story sifting in action. So these are some examples of story sifting in the real world per se. The first example is Why Are We Like This? So this is a project that came out of the Expressive Intelligence Studio. This is work by Max Kraminski and Melanie Dickinson. And essentially what they are doing here is using story sifting behind the scenes to create this co-authoritative game where players are collaborating to produce this narrative transcript of events that transpire between these characters that you see at the bottom. And then there's Bad News, which is most of the inspiration for this project, which used story sifting more in the manual sense, where in Bad News, for those who aren't familiar to start off with, it's sort of a game that has 3 players. One player is the actual player. They are going through the world. They have the job of locating an NPC within that world that is the next of kin to a different NPC who recently passed away in a virtual town. And that player has to go about this task by interacting with the second player who is live acting the NPCs that they are interacting with. And then behind the scenes somewhere is this player who's more in a Wizard of Oz context. And what their job is to do is they live code at a Python terminal, because the whole simulation is written in Python, and they have to find characters for the first player to interact with. And that whole thing is a very hands-on process, but it also takes a lot of firsthand knowledge of knowing like how the underlying simulation works in order to navigate around the internal structure. And this quote here in this image is something that I personally wanted to like focus on here for this talk, which is like, this is a marvel of procedural performance, or yeah, this marvel of procedural performance can only be played by a lucky few, and that's a crying shame. And part of the reason why I think it can only be played by a select few is because of this lack of accessibility when it came to the wizard side of gameplay, because we all have some sort of acting ability. We can all play a game, but knowing how to specifically sift through and find a specific story is a little challenging. And so hopefully I would like that this project, it's still in its preliminary stages, but I would very much like something like this to help alleviate that problem. Yep, and then there's the citations. So now we get into Centrifuge. This is a screenshot of the editor. We'll see more of the editor later, but big picture here, you essentially have this canvas that you can drag and drop nodes onto. It has workspace folders, so you can put all your patterns into one place, and that helps you reuse them between patterns. You have an output panel here where you can see what the text-based version of your pattern is, and then you can rename patterns and like add new nodes. You'll see a lot more of this in the demo. And what we're doing here is encouraging creativity and accessibility. So code can be intimidating and frustrating for novice learners. That's a lot of the initial frustration, is just getting past the text syntax, the idiosyncrasies between like natural language and whatever coding language you're trying to learn. And if you do have minimal programming experience, sometimes the learning curve between what you're used to and sort of that computational thinking that is involved with programming can be eased by using graphical versus text-based approaches. And negative emotions hinder creativity. So in a space where we're trying to be creative in like interactive storytelling, having all this like frustration bearing down on you reduces your ability to like open up your mind to the possibilities and think outside the box of all these fascinating scenarios that characters could be in. And finally, of course, visual programming is an alternate to learning a textual syntax. So there's also that. What I have over here on the side are examples of story sifting in like just in general. So the first one, like behind this this black box here, is Python code that does some sifting in the Talk of the Town simulation, and then the one in front is actually a text query out of the Centrifuge tool that I use. So this is DataScript code. It's the same query language that is used in the Why Are We Like This experience that I talked about previously. And we personally drew some inspiration from like Unity's shader graph, because I'm personally not good at writing shaders, but I enjoyed this tool, and Unreal 4's blueprints. So these are both two good examples of node-based approaches sort of being used in the wild and having some amount of success. All right, so demo time. So for the demo I have, I'm gonna sort of split it between two things. So I have a video that I'm gonna narrate over, and then I can poke around in the editor to sort of show you some stuff live. Okay, so I'm 10:13, I've got a little bit of time, I'm doing good. Okay, so the video, this video is about 2 minutes. So here, this is just the general editor. So like you got your whole node canvas going on here. You've got all these different types of nodes that you can select from. And in this next clip, I go through and I author what I'm calling a modern Hamlet. So it's basically a Hamlet pattern that involves 3 people, and there's a son, a father, and an uncle. And the uncle just has to have a negative relationship with the father. So, let me, 1 second, let me see. I don't know if I can make it bigger since it's a video. You know what, I can switch over to, this will probably make it easier. Let me just show it in, because the video is basically a time lapse, but I can pull out the actual thing right now and sort of zoom it in. That's out. Okay. Ooh, I didn't change anything. Okay, how does that look? Is that better? I can also change I think I can change the resolution of the screen without it messing up. Okay, cool. Okay, so this is the Hamlet pattern. So you've got the son, the father, the uncle. These are all what we call entity nodes within the editor. The patterns break down to that data query, or that data script syntax that you saw before. So what I would plan to use this with is a partnering database that is also a data script database, because the query language and the database sort of come together in this nice package. And entities are how we collect up values in the database. And so I would represent different pieces, entities within the simulation as entities in the database. So you'd have people, you have relationships, businesses, like events, stuff like that. And so here, these 3 orange nodes, that are stacked on top of one another are all people nodes. I've named them after the characters that they're supposed to present or represent. And between them, I have like social connections set up. So this first So this first node is the son of the second node. So it's the son is the son of the father. And then the father is the brother of the uncle. And here I have this relationship node that just says, okay, so it's jealousy. These are one-way relationships. So it's the way that the uncle feels about the father, and the way that relationships are modeled. This is using the Talk of the Town. It's based off of the Talk of the Town simulation, which represents relationships using two floating point values. So there's like charge and spark, and charge is your level of like general affinity for a person. So if it's negative, then you don't necessarily like that person. If it's positive, then you like that person. And here what's going on, that's a typo, is I'm just looking for a relationship between those characters that has a charge value that is less than 0.5. And what would this look like in as like a actual query? So we can actually take this, save it, and I'm gonna generate this and then like move the code over to like a VS Code thing so I can blow it up, because it's going to be pretty small at the bottom now that I know. But you can click compile and it gives you back what this query would look like. And then down here is some extra output for the other patterns that are within this same workspace folder. So if I can copy that. Come here, VS Code, where are you? And there we go. Okay. So this should be pretty visible on the screen. Basically, it's the same general setup, but just in code version, and you could pass this directly to I'm sorry, you could pass this directly to a database instance if you wanted to, and assuming that you had all the information set up, it would work the way that you expect it to work. So you've got like your find thing up here, which just says, all right, these are the variables that I want you to bind to find in the database and return back to me. This is just some boilerplate that just lets it know that we're going to use like external roles possibly and what database instance to use. And then down here are all of our logical like query clauses that are defining, okay, what are the variables you need to bind? What conditions do they need to satisfy? And assuming that it satisfies all of these, go ahead and return what a set of the bound variables that you find back to the user. So I think that puts me at